Welcome to Digital 360 Summit 2020. We are the premier event for senior executives driving industry digitalization, decentralization, and decarbonization. 2020 edition is a free virtual event via Zoom. The dates are August 18th, 19th, and 20th, 2020, and August 25th, 26th, 27th, 2020. We want to thank our sponsors, Texas State University, Greater San Marcos Partnership, and Cedar. This year's edition has 70 speakers from amazing companies like NASA, Intel, SAP, CPS Energy, Brazos River Authority, Katera, Direct Energy, City of Austin, Aclara, Dell, Engie, Exelon, Oracle, Tesla, General Motors, TXDOT, Vistra, Siemens, AT&T, National Grid, Itron, City of Los Angeles, Austin Energy, City of Colorado Springs, and Hunt Energy Network, and over 1,000 attendees. The program has 16 keynotes and 11 panels, followed by 11 white papers and 28 videos. The event covers multiple industry verticals like networks, energy and utilities, buildings and infrastructure, water and wastewater, public safety and new financial tools, smart cities, sensor and edge computing, big data and software, smart mobility, new regulations and business models, space and smart factory, and Industry 4.0. We are also introducing Texas State Cedar, a new industry research consortium focused on connected infrastructure research enabling big ideas and the topics covered in each of the panels. We at Texas State, Star Park, Cedar, the Greater San Marcos Partnership, and industry partners are focusing on building 9 living labs to transform applied research and economic development with the goal to delivering one digital world.
Welcome to the Digital 360 Summit Day 3. We're delighted to have everyone here, and we have a phenomenal panel lined up for you. But before we get there, let me tee up the next video, which is about Cedar that we briefly just talked about, which is a consortium style research organization focused on industry in collaboration with industry and accelerating industry research. And we want you to know about it real quick. Let me share that for you and run that video. Hopefully you all can see that. Here we go. Well, thanks for being here, everybody. And again, delighted that you are joining us. And we have a sensational keynote and panel lined up. And let me just cut to the chase and introduce you to David Collinsworth, the Chief Executive Officer and General Manager of Brazos River Authority. David, how are you?
Doing great. How are you?
Outstanding. Well, David, this is your show. I encourage everybody to mute themselves while David is doing his keynote, and we'll come back to you for the panel. David, you want to share your screen and take it over?
Certainly.
Go for it.
All right. Did we successfully do that? Can you see my screen?
Yes.
Okay, well, I'll get started. My name's David Collinsworth. I am the CEO, General Manager of the Brazos River Authority. I will spend a fair amount of time talking about the organization that I represent. From the 30,000-foot view, kind of what I want to do is, with this digital theme, I want to give you just kind of an overarching perspective of the water business. And then we will tie down into a little bit more detail and maybe for those of you that are listening that aren't from Texas, you'll be able to maybe relate some of the challenges that I'm going to talk about through the water and wastewater world with what you what your challenges are in your industry. Let me start my timer there so I don't talk for 2 hours. And Jim, you have quite a challenge keeping me on task here, so feel free to butt in and speed me up or slow me down. So Andres, first of all, I'd just like to thank you for inviting me to be a part of this. As a Texas State alum, it is really exciting to see what the university's doing, to be a part and watch Cedar grow and understand what you're doing for the up and coming young professionals in Texas, which means so much to our workforce, and what you all are doing as far as helping develop the industry of water and wastewater and other industries that are going to continue to grow and be such a part of Texas. So let me jump right in and tell you a little bit about my organization, and then we'll start tuning in from the 30,000-foot view. So what you're looking at there is a map, obviously, of the state of Texas. I represent the Brazos River Authority, and we are a governmental entity, a pretty unique entity that was developed back in 1929 to manage water resources in the state of Texas. So to put it in another perspective, the state of Texas owns all of the water within the state boundaries, and they use river authorities such as the BRA to help manage that water, help contract that water with municipalities, with industries, help manage water quality issues, help build reservoirs, help manage infrastructure, in some cases help provide treatment capacity, wastewater treatment opportunities in areas that need those. So this area that I'm showing you here is really not a jurisdictional boundary because we're not a regulatory agency, but it is the watershed of the Brazos Basin. So any rainfall that lands there, or any water that percolates out of the ground would be of interest to the Brazos River Authority and how it relates to our ability to store water. We're roughly 42,000 square miles. That's about the same size as the state of Tennessee. And there's 3 million people in our basin. So you might think, well, that's not a whole lot of people. But what I'd really like to point out on this map, if you can really put your readers on and zoom in, from Fort Worth, Texas, down to Waco, down to Temple, down to Austin, down to San Antonio. If I were able to draw you a line there, that's the I-35 corridor. And that provides, that is the beginning of infrastructure for almost 15 million people. And I would tell you that if you go back and you look at growth numbers and housing starts in 2008, when the United States of economy was starting to go south, it wasn't going south along that I-35 corridor. And I think what we'll learn, and talking to some of my municipal customers, that even with COVID-19, there may be a blip there in new home starts, but as far as the economy goes, there's been a different economic impact along that I-35 corridor than in other parts of the country. Or said another way, some of the fastest growing communities in the United States are along that corridor. The greater Austin area, Round Rock, Temple. So it's a real unique area. Back in 2001, we had water in our portfolio, that we couldn't give away. And now we have a shortage of water on the books for long-term water needs. And at least for the next 20 years, we'll have that shortage because we have so many people that are moving into the state of Texas in that area. The other thing that I'd like to point out on this graphic, which is pretty unique, if you look there at the geographic coloring of the map, you see the darker greens down toward the Gulf of Mexico and the browns toward Lubbock and Amarillo. The river systems in the state of Texas are really unique. Most other parts of the world, a river starts in an area where there's a lot of rainfall or a lot of snow melt. And then those rivers travel through more arid regions into and ultimately dump into an ocean. It's not that way in the state of Texas. The headwaters of the majority of our major rivers in the state of Texas start in very arid regions. So I tell people all the time when we're talking conservation and water usage, you need to remember that I-35 in that corridor, that's kind of the gateway to the desert. There are other river authorities in Texas. There's the Lower Colorado River Authority to my south. There's the Trinity River Authority. All in all, there's about 20 river authorities. We're all very different. We're all different sizes. The Lower Colorado River Authority there that encompasses the greater Austin area has a couple of thousand employees, where I have a little over 300 employees at different times of the year. So we're all very different. We were created by the legislature We do not get appropriations from the legislature, but I do report to a board of directors that it's a 21-member board that is appointed by the governor and approved by the Senate. They serve, each board member serves a 6-year term, and they meet with us to help set policy and provide direction both financially and help drive where the organization is going. So again, we're a water supply organization. Very simply, the state of Texas has water. They own the water. They permit that water to us. And these are the reservoirs that we use to store that water. It is a very unique reservoir system because not all of the reservoirs are on the main stem. So in one of the most significant droughts this part of the state of Texas has ever witnessed was 2011 through 2013. While we had parts of the main stem of the Brazos that were actually dry, at certain times we were releasing water from other reservoirs because we were having rain events. So the reservoirs on the tributaries are very significant in our ability to operate water and release water out of all these reservoirs. And I'll tie this in for you in a minute because you'll begin to see how we release water for our customers and how our customers acquire that water and where they're located. But I'd point something out to you that's very important. The Brazos River Authority owns and operates 3 reservoirs: Possum Kingdom Reservoir, Granbury, Lake Granbury, and then Lake Limestone, and they're in the red. The other reservoirs, the ones that are in yellow, are owned by the federal government, the U.S. Army Corps of Engineers. And we have a contract through them to use their reservoirs as storage facilities. Their reservoirs were built back anywhere from the 30s through the 60s their major purpose was for flood storage, with a secondary purpose also being water supply. The reservoirs that my organization owns and operates are only water supply reservoirs. And we'll talk a little bit more about the significance of that also. But then also down at the bottom, you'll see there's a little black dot, and that represents Allen's Creek Reservoir. That is a reservoir that the city of Houston and the Brazos River Authority are trying to move forward and build. And it will be one of only 2 or 3 reservoirs that will probably be built in Texas for the remainder of my career. And I hope to work 20 more years in the water business. I've been in the water business now for about 27 years, and I haven't seen many reservoirs built in that time. And we'll talk about more of the challenges of building those water supply reservoirs. So to give you a little perspective, here are our largest customers, and we have well over 100 customers that contract water for us, but these aren't the most important ones per se. These are just the larger ones that we have. And I wanted to show you this because I wanted you to see where they are in relation to those dots that I showed you. If I can go backwards here, I'll try. If I can go backwards, see where the dots are located. They're either up here in the northern regions of the watershed, or they're here in the central regions of the watershed. But only the new reservoir that we're proposing is down south. And you can see where those customers are. So we release a lot of water from all of those different reservoirs to meet these large downstream needs. Dow Chemical is the largest petrochemical refinery in the United States of America. Gulf Coast Water Authority supplies water all the way to parts of southeastern Houston metro area, all the way out to the Galveston Island. They also supply water to a company that is a seed rice producer that sends rice seed all over the world. This biggest red dot here at the top is TXU Luminant. It's a nuclear power supply facility. And then Bell County WCID here, the biggest blue circle right there in the middle, provides water to 2 or 3 very large metropolitan areas. And then also the largest military installation in North America, which would be Fort Hood. So the water supply that we are managing has some really critical end users. You know, the interesting thing here from a philosophical perspective is we've kind of got this business all wrong. And it kind of goes back to how our rivers flow. So we've got all these reservoirs that are located here in the central part of the basin, and we release water out of those reservoirs for large industrial and municipal users that their offices are really close to the ocean. So you know, one day desal water, taking the salt out of the ocean, will be a big part of the Texas water portfolio. It is not today, and I will tell you why. Because if you live in most parts of Texas are probably blessed with paying anywhere from $2.50 to $5 per 1,000 gallons of water used. The cheapest desal water that I have seen for municipal use is somewhere north of $12 per 1,000 gallons. And that doesn't include the cost of moving it from point A to your faucet. So we're a long way off from having desal as a part of our portfolio, but it will be there. And I tell people all the time when they ask me, or if we have another drought like 2011, are we going to run out of water? No, we survived the drought just fine. We're not going to run out of water. But sometime in the future, the question is going to be, what are you willing to pay for water? So that's one of the big challenges that we have in trying to develop water for the future. This is what I introduced you to, our 3 reservoirs. I'll give you a tour of them real quick. This is what Possum Kingdom Reservoir looks like. Here's another picture of, well, let me go back. I'm sorry. This is what Possum Kingdom Reservoir looks like. It's almost 100 years old. So it's from talking at a digital symposium, it doesn't have a whole lot of digital in it. There's a lot of challenges there with those type of things and operating reservoirs. You can see here again, the reservoirs that the BRA owns, and then the reservoirs that we have with the U.S. Army Corps of Engineers for water supply. Those reservoirs there provide almost 800,000 acre feet of water to the Brazos River Basin. An acre foot of water is just how you would imagine. It's an acre, like if you had an acre of property and you flooded it a foot deep. That's how we sell units of water, or contract for water. We also move water from reservoir to reservoir. We have one 28-mile pipeline, but we have other projects on the books that will end up moving water from where it is to where people are moving. We talked about the I-35 corridor, and there it is there, and you can see that pipeline on the far right-hand side of that slide. And being able to move water to where people and industries are developing is a real big deal. The slide that I showed you a minute ago with our top 10 customers, when Dow Chemical wants water, they simply call us, and we determine which one of those 11 reservoirs we want to release water out of based on a whole bunch of different criteria, and we put it in the river. And then 5 or 6 or 7 days later, depending upon river flow and other things that are happening, they take it out of the river. So it's a pretty simplistic way of moving water. It's not the most efficient because you have channel losses and you have evaporation, but it's how we do it. This is something that I wanted to introduce to you because from the digital perspective, how we use scientific data is becoming more important. We spend a lot of time doing water quality analysis, and when we send a crew of scientists out into the field and they take a water sample, that water sample represents the water quality in that water body, that stream, that river, that reservoir, but it only represents that one point in time. So what these folks here are doing on this slide is they're taking biological samples because really by getting out and understanding the flora, the fauna, the ecological diversity in the stream, the population diversity in the stream, we can better understand how healthy the aquatic environment is. And that really helps us grasp and understand better the long-term impacts of what's going on in a watershed. So we're able to use this biological data for a really in-depth view into what's going on in the stream and how making sure that we understand water quality and how different activities are impacting water quality. This is the slide I was trying to show you a minute ago, Possum Kingdom, almost 100 years old. Those gates drop and water comes over the top, and each one of those gates that you see on the far right that's spilling water, that's 9,000 cubic feet per second. So it's a very beautiful place. Again, in a few years, it'll be 100 years old. And right now we're doing a major study to determine the impacts of the concrete inside the dam because we are really planning to use this infrastructure for another 100 years. The replacement cost of something like this, while it was built back in 1941, I believe for less than $30 million, the replacement cost would be well into the billions. And we don't want to burden our ratepayers with that. So we're very proactive in making sure that we're taking care of our infrastructure. Our next reservoir that we own is Lake Granbury. It's 134,000 acre feet of water stored behind it. It was built in the 1960s. And then our newest reservoir, I say it that way because reservoirs just don't get built anymore, is Lake Limestone. And it was built in 1978, and it stores behind it 204,000 acre feet of water. So, you know, to start talking about some of the challenges in the water business in Texas, I want to show you this. And this is how our water is contracted. About 52% of it is municipal, and about 42% of it is industrial. And you see a little bit there for irrigation, a little bit for mining. You know, I told you that there's a water shortage. So as we develop more water, there's always going to be competing interest on who gets that water. How do you prioritize it? Is it going to be municipal? Is it going to be industrial? You also have to determine, you know, how much of that water needs to stay in the reservoirs and be discharged into the river systems for the environment. There is a very strong industry of recreational boaters that want the water to be in that reservoir for recreation. You can't discount that. So there's always going to be these challenges on, once we develop water, who gets it. I talked a little bit about how you operate a reservoir from the perspective of flood storage when the Corps of Engineer reservoirs were built. The Corps of Engineer reservoirs hold water during times of significant rain. Some of that water gets released, some of that water gets used for municipal and industrial, but the reservoirs that we built don't have any flood storage at all. So when they're full, every drop of water that comes in the reservoir has to equal a drop of water that leaves the reservoir. So let's talk about water shortages. The state of Texas back in the early 90s just did an outstanding job of responding to earlier droughts, and we started what's called the state water planning process. And this is a product of that. And this was produced in 2017. And this shows you the Brazos River Basin, and it shows you the shortages. It kind of identifies where there are shortages. Now, it's not as grim as maybe this map makes it look. A lot of the shortages that, if I took you down into the detail, a lot of the shortages here would be based on the need for more treatment capacity or another pipeline or infrastructure per se. And in the world of treated water, I sell wholesale water. I need water supplies that are available years and years before they're needed. Your municipality or who treats your water and sends it to your tap, they don't want to get too far ahead of the needs because you have to pay for that infrastructure. So their strategy a lot of times is building it right before it's needed. So that's depicted here on this map also. But there also is just a need for more water in Texas, all up and down the I-35 corridor. And then over here, I hope you can see my cursor near Fort Bend County and Brazoria County, tremendous industrial growth. And that's where the city of Houston, the suburbs of Houston are growing out into that area also. So how do we meet those needs? Well, we do, first of all, we're looking to build reservoirs. And one of the reservoirs that we're looking to build is Allen's Creek. It's very unique in that it's an off-channel reservoir. And what I mean by that is we're not going to dam, we're not going to put a piece of concrete in front of the Brazos and store water behind it. We're going to build a big holding tank off to the side of the river so that when Mother Nature does her job and provides water and we're having to release water out of those other 11 reservoirs, when the time is right, we can pump that water out of the main stem of the Brazos and store it into Allen's Creek Reservoir. And it will yield, firm yield will be somewhere around 100,000 acre feet of water at the cost of about $500 million. That's a really cheap reservoir project. And that dollar figure does not incorporate the fact that we already own the land and have the water permit. Something else that we're looking at doing is working with the U.S. Army Corps of Engineers in studying the water that's already in their reservoirs, specifically Lake Whitney, a ginormous reservoir that has a lot of water that's not allocated to any one particular source. And then there's also some water that's allocated to electrical generation. And because electric generation is so much more efficient today than it was 30 years ago when this water was allocated for electricity, we're asking the federal government to go back in and figure out and study and hopefully reallocate some of that water for downstream use into Texas. As I talked about earlier, we're looking at moving water from where it is to where the people are. So we'll always be looking at building pipelines, and that's what these two maps show. The yellow on the far right is a very prolific groundwater aquifer called the Carrizo-Wilcox, and we're looking to pump water out of the ground into Williamson and Bell County, which is just north of the Austin area, and use it conjunctively with surface water. So the theory would be when Mother Nature's doing her job, you're pumping it out of the reservoir. When you start entering into drought periods, which we do about every 7 years here in Texas, you can start leaning a little bit more on your groundwater, and you kind of get the picture. You use the two conjunctively to take advantage and to use the cheapest water possible and take advantage of both water supplies. And I know I'm running out of time here, but I really wanted to get to this slide because this kind of boils down whether you're in Texas or whether you're in other parts of the United States that are growing. Here's kind of some of the challenges that we see. And that is, you know, how do you prioritize water? There's, at least in parts of Texas for the next 20 to 40 years, there's going to be shortages for the long-term need. And when I say long-term, I'm talking beyond 20 years out. Most of Texas has all the water it needs now for the next 5 to 10 to 15 years. So it's as you develop that water, who's going to decide how it gets used and what's the most important use for it. So that's going to be a political issue that will be resolved in state capitals. There's continued rapid growth all throughout parts of Texas that need water. You know, growth means people are coming, and when people are coming, they bring money with them. So that's a good thing. But the next bullet that you see in the development of new water supplies, most of the really easy projects have already been completed. You know, thank God for our forefathers that built all the reservoirs in the 30s and 40s and 50s that we're using those water supplies now. Because new water projects are always controversial. People don't want infrastructure built through their property. People don't want their local areas impacted by projects. So there's just a lot of challenges in very large scale projects that develop a resource or develop a utility. It's really hard to type sarcasm, but that's what the next bullet is. I have spent, our organization has spent the last 3 years fighting the United States Army Corps of Engineers over proposed water rules. I say this, I think the U.S. Army Corps of Engineers they were focused on fixing water challenges in Missouri and water challenges in Georgia and maybe water challenges in Florida. But a one size fits all didn't work. And really, you know, so many of the initiatives that we see coming out of different federal organizations look to challenge the water supplies and how we use our water. And so we're going to continue to fight. We're going to continue to fight over their initiatives and what works best for the state of Texas. Here in Texas, I've talked a little bit about growth, but the other thing that we're struggling with is what's happening to rural Texas. And really we're seeing areas where population is diminishing in those small communities. The schools are old, the pipes are old, the roads are old, the buildings are old. So there's just, for the people that are left there that don't have new folks that are moving in to supply tax revenues and to help pay for expansions and new infrastructure, rural Texas is a really big challenge on how we're going to fund projects and make sure that we protect rural Texas. And you can say, well, you know, they can go borrow low interest money and put in pipelines. Well, that's fine, but they just don't, in many cases, don't have the money to do that. And again, they're needing to build new schools and they're needing to build new, you know, this and that. So from the permitting perspective, let me talk a little bit about Allen's Creek and then I'll wrap up. The reservoir project that I showed you in Texas, you need 3 things to build a reservoir. You need a water right permit, and BRA and the city of Houston already have that. You need the property, and we basically have I'd say 99% of the property. We need a little bit more, but that'll be determined after final engineering. And then you need a permit from the federal government through the U.S. Army Corps of Engineers to build the reservoir. We are starting now on that permit. That permit, best case scenario, will take us 7 to 10 years and will cost us somewhere north of $40 million just to get the permit before we get the approval to build the reservoir. And part of that is because the world that we live in is litigious, and people will take every advantage that they can to oppose that project through a litigious process. And it just, the permitting challenges, whether it's trying to build a pipeline or trying to build a reservoir, the time it takes, and you've heard this before, time is money, is just sometimes overbearing. So, Jim, those are the slides that I had. I would really, if, you know, I kind of breezed through a whole lot of information very, very fast. For folks that want more information about what I talked about and want to understand more about the Brazos River Authority, they can go to www.brazos.org. And we have a lot of informational videos about operations and water supply and future projects. So I'm going to turn this back over to you.
Thank you, David. David, real quick, I just want to thank you for that beautiful keynote, and thank you for sticking around to the panel session, which I know is going to be fantastic. Let me introduce you to our moderator, Jim Good, who is a superstar, having worked in some of the largest water companies in his career. He now is the principal of Parkview Advisors, and we're lucky to have him to moderate this and really steer the conversation among all of you. Jim, the panel is yours. Please introduce your panelists, and thank you for being here and spending the day with us.
Andres, thanks for the introduction. And before we get started with some questions, I'm going to quickly introduce the members of my panel. It's extremely distinguished, and in fact, I think they must have made a mistake making me the moderator of this crew when I compare what they've done to what I've done. Let me just briefly introduce them, and then we'll get into our first question. And then no particular order. First, we have Dave Mackie. Dave is the CEO of Olead Edge Analytics. Did I pronounce that correctly? Olead?
That's correct.
Okay. And they have a patented solution that combines IoT and edge computing capabilities to bring transparency, accuracy, and reliability to the delivery of the world's most precious resource, which is water. It's an Austin, Texas company, and their method ensures that the payback for reducing leaks is reduced from years to just a few months. The next speaker is Tacoma Zach. Tacoma is CEO and co-founder of MentorAPM Asset Performance Management, which uses the latest software tools and knowledge to achieve excellence, resiliency, and sustainability. He's also got a subsidiary called Uberlytics, which deepens the support with business-oriented risk assessments, asset management development, and coaching from entry level through to ISO 55000 certification readiness. Tacoma spent much of his career in the industrial water and wastewater business and had the misfortune of working for me at one point in his career. Next is Terrence. Terrence McCarthy is a registered professional engineer in California. Spent several years working on projects in the wastewater sector for the city of Los Angeles, then moved over to the potable water side for Los Angeles Department of Water and Power, LADWP, where he's done everything from major capital improvement projects and program management to climate change studies on the Eastern Sierra. He's currently the manager of LADWP's Water Conservation Policy Group and joins us today from, I guess, the Eastern Sierra, judging by the picture, even though it says here, Los Angeles. And finally, we have Professor Keisuke Ikehata, and he is an assistant professor of civil engineering at the Ingram School of Engineering at Texas State University. He's one of the founding members of the new civil engineering program in July 2019. He received his PhD in civil and environmental engineering from the University of Alberta. And in addition to his academic experience, has a number of years under his belt as a consultant, not only in Canada, but in Kansas, California, and Texas. His research focuses on areas including advanced water and wastewater treatment, water reuse, desalination, stormwater management, and online monitoring in smart water infrastructures. In his spare time, he writes and has put together over 140 technical publications. So with that, I'd like to bridge the incredible presentation that Dave gave us about the situation that faces his Brazos River Authority and the water supply issue in general, with the topic of today's session, which is the digital utility. So maybe what I'd like to do is just go around with the four speakers and start and just ask, what is it that your entity does or you see in your everyday job that could help an agency, well, not like BRA, but BRA or agencies like it in doing their job more efficiently or better? Tacoma, why don't we start with you?
Okay, thanks, Jim. Well, you know, when we look at the magnitude of the challenges that David brought to the table, you know, an answer like this, or at least a discussion like this, we run the risk of oversimplifying things. But, you know, just for the sake of clarity and for the sake of the, or I guess the background of the experience that we've seen both in operating facilities across the West and with the customers, everybody wants to do a better job and wants to do an excellent job, but we're all going to have to realize we need to do more with less. So we have to work smarter. We need to significantly extend the life of those assets that we have. We're dealing with increasingly limited financial resources. So how do we do that? We've heard a lot about asset management and programs that have come into place. And so, you know, if we sort of conceptualize it, I think what we offer, what we do is we take the learnings that we've had over the years. We realize we need a strategy, we need tactics, and we need the tools to support these things. So in the two big ways that we do that is that we deliver on the functional aspects of an asset management plan, is we figure out what to do and when, and also providing the digital tools to do that. And on the what to do and when, asset management plans are a foundational aspect of that. And I'll say, you know, there's a one takeaway on that, as I'd say the order makes a big difference. You know, you've got to start with level of service, and then you've got to deal with understanding where your risk is. And then you do your asset condition stuff and understanding your assets. You save a boatload of money that way because we're dealing with decreasing financial resources. And then on the software tools, you've got to deal with the stuff or the data in the right way so that you don't create junk. You don't treat the data and offer an ability to capture the data at a granular enough level. And if you don't treat it as with an industry appropriate way of handling it, you're not really going to be able to generate information that you can make decisions from. And so those are the two things that we do is we offer this ability to set up some strategies and put the tactics in the right order, as well as providing the digital tools to be able to pull all that data together properly and treat it appropriately so that you can actually turn data into information to make decisions.
You're muted,
Yep.
Jim.
Jim, you're muted. Jim, you're muted.
Can you hear me now?
Yeah, we can hear you now.
Okay. I'll turn it over to Terrence. He comes from a water entity that's maybe the second largest in the entire country, and probably faces a lot of the same challenges.
Put the mic back, Jim. Put your mic back on. He can't hear us.
So I think Jim was trying to turn it over to me, and I can just jump in right where Tacoma left off on his asset management discussion and kind of highlighting the benefits and usefulness of an asset management program. But I also want to talk a little bit about you know, our experience at LADWP and addressing the issue of kind of changing your future in moving forward in the water world. We have recently released a Green New Deal when it comes to water prioritization and kind of where we get our source supplies from. As you can see behind me, it looks like we have a ton of available supplies in the mountains ready to roll, but that's not always the case, and we're finding that it becomes either feast or famine, whether it's raining buckets or dry as the Sahara. We have to kind of change our approach, and we've decided in our Green New Deal to approach our supply sources in more of a local strategy, and that involves utilizing more our local groundwater as well as our recycled water assets and stormwater capture assets to diversify our supply portfolio and make it more resilient in the coming future. And with the advent of all the digital advancements that we're seeing across the market come about, that's really going to help facilitate us moving this process forward. We've got over a century-old system here in Los Angeles that has over 7,000 miles of pipeline, hundreds of pump stations, tanks, reservoirs, and to kind of change the operations and make a third aqueduct, if you will, with recycled water and facilitating that, it's going to require a lot of technology to not only do water quality monitoring, but also the notification and the granular data that we're going to need to make informed decisions moving forward as to how we run and operate our system. So I'll leave it there so others can chime in.
Okay. I'm hoping you can hear me. Somebody give me a thumbs up. Okay, great. All right, awesome. Thank you. 6 months into it and I still can't master Zoom. Keisuke, how about you? Why don't you tell us what's going on in with your grad students, your lab, your papers that could be of help to David.
All right. Well, I didn't really think that I'll be the next, but let me try. All right. So I think Tacoma and Terrence gave a very good overview of what the digital water really is in our daily lives these days. I'd like to kind of provide additional perspective from academics' point of view, because we are always interested in advancing more technologies, you know. So one thing I really like to kind of introduce, many of you probably know, is a digital twin technology. The theme I keep hearing from Tacoma and Terrence is we're gonna collect a lot of data from existing infrastructure and systems and using the data to make us sensible decisions. I think that using new technologies, new sensor technologies and computing capabilities, we can create a kind of digital replica of physical entities like a wastewater treatment plant, water treatment plant, could be a whole entire water distribution system, water resources management system, to simulate the different types of water, crisis scenarios, such as high demand, low demand, water quality challenges, algal blooms, accidental release of toxic materials, and of course pathogens. Like, I don't want to name this pathogen, but we can utilize existing infrastructures and we using advanced computing technology. By the way, I'm not doing digital twins at Texas State at this moment, but this is something I'm very interested in pursuing here at Texas State in the future. So I kind of like to give additional perspective on what is already existing, but also showing, proposing additional work for us to do.
Okay, thanks, Professor. And Dave, you're batting cleanup.
All right, I like it. Batting ninth, good deal. So first off, gentlemen, thank you for inviting me to this. It's been very interesting. And David, Mr. Collinsworth, I was very interested in your presentation. It was really fascinating. I don't get to see how water is actually created very often. We're doing with the supply side. But a lot of what we do functionally is the digitization of non-digital assets. That really is our business. Our primary focus at the moment is water meters and commercial water meters more than anything else. And we do a tremendous amount of digitization of this, basically turning them into something that you can actually visualize and see in real time. A lot of our core competency is based around solar-powered, battery-operated systems. And that gives us the ability to distribute these assets all over the cities in a very meaningful way. We add sensors and other stuff to them, and it gives us a real view into what's going on. And we see the future of water management, especially treated water management, as really critical, because the cost is going up. Water is definitely cheaper on the supply side before it becomes treated. After that, it becomes a far more valuable asset. What people don't realize is that the process of billing and managing of the asset you're delivering does pay for most of the infrastructure improvements that are being placed around these cities. So our focus is on digitization, creating digital representations of the processes. But the other thing we're really focused on, and I think is a huge area for everybody to really start considering, is artificial intelligence and machine learning based upon visual inspection of certain things and being able to determine what's going on with them. And we are expending a lot of energy in this area. In fact, we're using edge TensorFlow processing units that we have from Google. I don't want to talk too much about the vendors, but the idea behind this is we push the resolution of artificial intelligence and machine learning to the edge. And that's something that's very, very new, because the technology that exists now didn't exist 5, 10 years ago to do this type of stuff in a functional manner. So if you think about the need to manage water and the need to manage the flow of water through the piping systems and the need to manage leaks and the need to manage the actual delivery into the infrastructure from a building perspective, those are things that we see as being really critical. The ultimate vision for everybody, I think, and everybody probably feels the same way on this, is having a dashboard where you can literally see and drive actionable actionable outcomes by deploying enough technology on top of the existing ecosystem so that you can get a good view and then figure out how to best manage your money and limited resources moving forward. So we're pretty encouraged actually with the pace of technology change. I know Terrence was talking about there's a lot of technology available out there. There sure is. Our focus on it though is in the distributed places where there's no power. There you have to build something that is self-managed and really can function on its own, and then provide a meaningful outcome that you can send back if something actionable occurs. And we're really excited about where this is going, and we're encouraged to see that we're seeing a good uptick in what we're doing. But what the real focus here, though, for us is digitizing assets so that actionable items can occur out of the digitalization process that provide us a better management system on the whole. So that's where we see the future moving.
Hey, let me ask a question. We're a bunch of water people on this panel and listening in. You used the term, I think, edge computing. Can you give us a very high level explanation of what that is? And remember, we're water people.
Yeah, that's fine. Well, I'm actually becoming a water person, even though, frankly, I was never one. And the more I learn about it, the more respect I have for people that do it. Because, frankly, it's a very thankless task on the most part. People just expect it to work, you know. And if it's not working, well, then why isn't it working? We're paying for it, you know. But they don't realize the amount they're paying for it versus the amount of cost usually is a huge differential. Edge computing, from our perspective, is true edge computing. Most people view edge computing as collectors sitting at the edge. They've got a pipe associated with them with some sort of Ethernet cable and power and those types of things. What we consider edge computing to be is right at the very source of where the information needs to be collected, placing a computer and enough intelligence on that so that it can actually behave in an autonomous fashion. So we view edge as being autonomous edge, self-powered edge. All of our devices we have over all the cities we're interoperating with operate independently of the power grid, operate independently of any sort of centralized intelligence. And in fact, one of the things we have, and I don't want to talk too much about this, except that it's interesting, is how we're implementing blockchain to track assets across the digital ecosystem. At some point, the data coming off of these devices we're producing that manage the information flow back in have to be verifiable. They have to be able to be provable that this data is real, it's actionable, and it's meaningful. And so the technologies that are being developed now to overlay on top of this are really interesting. So imagine you've got a device sitting out in a meter pit someplace 1,800 miles away from where you are. It's producing data coming off of it. It's being encrypted. It's being ledgered with the blockchain system, and it comes back in, and then decisions can be made collectively. The next stage for edge, though, for us, and this is where I'm really excited, is the idea of placing intelligence on the edge systems that have become self-aware. Now, it sounds a bit weird when I say that, but what we're really talking about is being able to communicate with each other about problems they're seeing to see if they do see a commonality of problem before it becomes something that gets brought up as a real issue. And that is very much within our grasp now. We just have to actually put it together. And there's some fascinating information that we're gleaning off of this. Now, one thing that Tacoma said, which I think is very interesting, he was talking about, hey, we need to cleanse the data, look at the data, make sure the data is real, we understand the data. One of the big advantages we have is we create the data. It's data created by our own sensors in our own infrastructure. So we have a lot more faith in that data than you would have in necessarily something that's just coming off of an ecosystem you have to look at. And that is one of the big advantages of edge computing in our perspective, is the source of the data and the quality of the data is very good. And it's being created at the edge in a distributed environment. So that's how we see edge computing: autonomous, self-aware characterization of assets in the distributed ecosystem.
Dave, thank you for that definition. I've always kind of wondered what that means, and I think you explained it very well. Let me ask the next question, and this is one that I'm really interested to hear what you folks think, and maybe David Collinsworth can jump in on this one too. But what is a digital utility? There's 5 of us here, 6 of us here. We might get 6 different answers, but I've got 2 people working for utilities. So, Terrence, why don't we start with you? What does that mean to you to say I've got a digital utility?
So, I mean, I think for one, a digital utility is a utility that uses technology to better serve our customers by, both doing it in the most efficient way and generating the highest quality, most sustainable, reliable sources that we can, but using the technologies to make those actionable decisions. And also, explore other alternatives. But one thing that, we haven't really talked about is on the customer side of things. And, we talk about how customers may not be aware the work and effort that we do, and they may not even be aware as to how much water they use and what they're using it on, which brings about the whole idea behind AMI technology or automated meter infrastructure, if you will. And that's something that I think is kind of that elephant in the room, because if our customers don't understand how they're using this asset that we're providing for them, they may not realize, that either they could be wastefully using it, or they could be utilizing a resource that is much more valuable than they may think when they just turn on a tap and let it run. So just to kind of throw that out there as a perspective, and with everyone now having a smartphone with them wherever they go, they have access to all of that data right away to see and make actionable decisions as they go throughout their days.
You're muted, Jim.
So reinforcing the value of the underlying product you're providing. Yeah. Okay. Dave Collinsworth, how about you? You've got a utility that you manage. What does that mean to you to be a digital utility?
Yeah, to be a digital utility, it's something that we've been looking into for years at different aspects. It really means to me collecting data and getting the data in the decision maker's hands instantaneously. And that, at times in the wastewater world is critical, and the drinking water treatment world is critical. Being able to determine leaks is critical. But let me give you another example. When we manage these reservoirs, when it rains upstream, we have rain gauges through contracts with USGS and others, and we have some of our own rain gauges. And that digital information provides us real-time information on the rain that's falling, so that we can begin to make releases and contact emergency coordinators. So that's just another example, but it really means, to me, it really means working smarter, not harder, and getting the data in the hands of the people that need to use it immediately. And we're all going there. I'll give you another little twist on it also, because Terrence mentioned the customer and the end user. By having more by having more digital information that we can make available at a moment's notice, it also allows us to be more transparent in what we're doing. So when we get to the point in time that we need to stand in front of our ratepayers and say, here's the millions of dollars that we need to spend, it really helps us back into how we created our rates and how we went through risk assessments and asset management to come back to them with, you know, here's what we need to do and here's how much money we can save you to better prolong the asset and those types of things. So that's what it means to us.
Okay. Tacoma, you want to field this one too?
Sure. Yeah. You know, drawing from the experience of the number of the refineries that we used to manage and the Western United States with the municipalities, you know, I look at there's a wide swath of what a digital utility means to different folks and what we've seen. And to be honest, the answer isn't one answer. And so while you can sit there and model everything, some things are going to be a little bit too chaotic, a little bit too difficult. And to be quite honest, I also think that not all data is created equally. Like everything else, you need to prioritize. And so there are going to be systems, there are going to be assets, there's going to be aspects of your infrastructure that are far more critical and far more risk-inducing to your level of service and your operation. And so I think that makes sense in those areas to have real-time information. And whether it's a distributed device that's on the edge, which is, I think, is a great technology, and it's providing information, is particularly valuable from remote locations if, you know, if there's a big lever associated with it too. Versus some things that, you know, gosh, if something breaks, you know, you could probably defer it. And so there's everything in between. And so I look at it, when I look at digital information, there's on one side, there's the modeling of it. There's another side of it is just capturing data. And I think one of the key things that David just mentioned, you know, where real time is important is particularly with one of the things that we've done is integrate a mobile application that allows you to instantaneously capture information from the most granular aspect of why an asset failed, its context, its condition, what's going on, and be able to update, you know, your overall EAM instantly, so that information is instantly accessible to the senior management, the engineering department, even the city manager if necessary. And so decisions can be made rather quickly. And some information, you know, it's okay if it lags a little bit. So the answer, I think, needs to be context sensitive to the utility's maturity scale. I think it also needs to be relative to what information needs to be acted on very quickly. And that would be, I think, to be honest, driven by the risk that those particular aspects of the infrastructure pose. And then deciding, you know, where are you going to apply some technology that you're going to put a remote piece of equipment in, whether it's hooked into SCADA or not, or you're just going to use people, or you're okay with going out and capturing something that's an hour on an hour meter. So I think there's a huge scale in there, and I think it's sensitive to the context of the utility itself. And even within the utility, there's going to be regions that are just not going to be as important as others.
Sure. Dave Mackie?
Yeah, so the biggest issue we see with digitalization, I'm sure you guys are seeing this, is just paying for it. I mean, it's expensive. And there's technology out there, and some of it works, some of it doesn't. One of the things we're focused on, I don't want to oversell this, but it's just kind of reality of where we're operating, is we're focusing on assets where if we can identify a problem, there's a quick ROI. And the ROI is sometimes 5, 10, 15, 20 times the cost of our equipment. And that can all be done in less than a year. If you can become a self-funder of a digitization strategy, which is what we do, it's really interesting from that perspective. Dollars are hard to come by. One of the things that Tacoma was just talking about, and I completely agree, there's a bifurcation of data for sure, whether some of it's real time, some of it doesn't need to be real time, some of it could be more dependent upon decisions that aren't necessarily needed real time. What we're moving into now is things like pressure sensors and bypass valve sensors and things that are ancillary to what we do on the actual commercial meters themselves. And those types of things are very actionable. We need to do something quickly. We need to understand what the pressure is doing more holistically through the piping system, those types of things. So we're seeing a move from sort of information flow that is not necessarily immediately actionable to immediately actionable information as we find more and more areas within the utilities where we can add value. And I would say that the bottom line on this more than anything else is the dollars to fund the programs forward and a reason to want to do it are really the things that get people moving. I think the other thing we see in the space that is sort of interesting is at the operational level versus the finance level, and these are very different areas in utilities. The operational level is focused on, hey, we got a job to do. We're mandated, we're working off a plan that was created last year. We don't really have a lot of time or space for this right now. I'd love to do it, but I'm just too busy. And so how do you create processes around it where you can enable the digitization of assets without it causing a lot of pain to the operational aspects of the utilities? And frankly, I will tell you this, we focus a lot on trying to work with the operational people far more focused than you would on the finance side, just because of the amount of effort they've got. They're retiring, they've got guys that are overworked, they've got projects that come up all of a sudden in a reduced budget situation. So anything you can do to provide additional funding into the utility and greater visibility in the utility, not that it causes people to be in a situation where their jobs are being made redundant. We think what we do creates focus for the people that are in the utility so they can operate in a more efficient manner. And that's a win-win for everybody. But having said all that, I completely agree. Data is data. Quality of data is really critically important. And the real-time nature of data is becoming more and more pronounced. So I do think we're moving that direction very quickly.
All right. And Professor, your thoughts on that question?
Well, sure. I gotta shift the gear a little bit because now I'm in academia. So I used to be in the consulting world. So, well, as an educator, digital water is something I have to incorporate into our curriculum. And in fact, at Texas State, our undergraduate civil engineering program is one of the very few in the nation with emphasis on application of technology to the life cycle management of infrastructures and asset management, including water. So we call it technology enhanced infrastructure, TEI. And this is what we are dealing with, and that's our digital utility. And this is kind of ironic. In the university academia, people think that we are all advanced and always talking about new things and new development technologies and all, but we actually has two extremes. So we certainly study and research brand new cutting edge technologies, but in the classroom we tend to use decades old textbook which has nothing, no contents in the digital utilities, smart water. So we have to come up with better case studies. And what I like to kind of ask you guys is give us more good case studies that we can incorporate into a curriculum so that our graduate will be ready for the digital world. I mean, they're already living in a digital world. Just want to make them a digital water people. So that's my take.
Yeah, they're waiting for us to catch up with them, and most of them are our children. So we've got about a half hour left, and we wanted to see if there's Q&A from the audience. I see that a couple have come in, and maybe Andres has picked some up as well. But one of them, and Dave Mackie, looks like you've volunteered to field these, but let me read it. It's from Rick Cutter. It says, are there new technologies or processes you have employed based on the fact you can't cut off customers that won't pay because of the COVID situation?
Yeah, look, this is a significant issue. We see this all the time. Utilities really struggle with this. On the one hand, they need revenue. They are a revenue generating machine within utilities. There's just no way around it. There's only three places they get money from: sporting events, special events, airports and taxes and those types of things that are driven out. And then the rest of it's water. And operating off of that, it creates a different pressure. However, we believe if we manage the commercial side of the operation effectively so that we are driving revenue to the full extent of what people are actually using on the commercial side, that does free up a lot of dollars that are not necessarily available for the residential stuff that's happening out there. So our premise is we don't want to be in the business of doing anything that hurts widows, orphans, low-income people, and people who are unemployed or out of work. What we're focused on is trying to lift the boat by looking at the commercial customers and making sure that what they're paying for is the full extent of what they need to pay for, because they can generally afford it. And that seems to be a much better place from a goodwill perspective to be than being in a situation where you're deploying meters that have automatic remote shutoff for people who can't afford to pay their bills. We're going to see more and more of this occurring going into next year, and it's going to be tough. It really is. So when the utilities we're working with, they see the value of driving commercial revenue as high as they possibly can within the limits of what they would be billing for normally, while trying to create some space for this particular issue with the pandemic and the unemployment issues and everything else to sort of blow over. And the other thing we're seeing, though, which is significant, is the budgets, while they're not necessarily being constrained in a huge way, they are shrinking. And that creates less money to do maintenance. It creates less money to do upgrades. It creates less money to do infrastructure improvements. So anything we can do, especially in an ESCO type funding situation, which is a lot of what we're working with companies like that, to provide funding that can offset the lack of revenue coming in due to the current environment, are really important to us. And we think that that's a benefit that we provide.
Anyone want to add to that?
Yeah, I think I'd like to add to that. You know, when we looked at the municipal operations, Jim, particularly the business that you and I were involved in before, I think one of the things that we saw with some of the challenges I think that Dave just brought about as well is that it's one thing to look at the industrial customers and try and raise that commercial part up, but there's also this massive loss, this non-revenue water that we've got to deal with. And we end up, you know, we found we had non-revenue water in a lot of different ways. It just leaked all over the ground or into the ground, or in fact it was poor treatment, or something was going wrong with equipment. And I found that one way to free up about 20% of the maintenance budget is to do things in a way that is a very structured, very tactical, very strategic approach. And I think if we look at capturing the right kind of data, since we're talking about a digitized utility, being able to act on that, and also looking at it and say, okay, what are the things that we need to do to those particular critical assets? A lot of times we end up just saying, well, hey, let's just go out and fix this and fix that and go and do our rounds. We can sharpen the focus so tight that we can say, hey, if it's broken, we may not even need to fix it because it's actually not posing that much of a risk to us. If it is significant in terms of having a significant impact on our level of service or operation, then we know we need to do something before it even fails. And I think what I think both of us found is that if we identify where we are at risk, we can prioritize those resources, prioritize some technology out there, and put things in place so that things don't fail before their time. Being able to extend the life of the assets far beyond what we traditionally sometimes just discount through. I mean, accountants love to just basically put a discount rate in. You go to the accounting package and the next thing you know, things are basically at zero value after 10 or 15 years. And yet the asset still has value to the organization because it actually still works or can work. We tend to do this in our private lives, the way we manage our vehicles, the way we do certain things, and or at least things that cost us money. We tend to manage those things better. So we need to take some of that just common sense practicality, bring it back to our work environment. And I think it's not unrealistic to assume that we can bring 20% savings to our maintenance budget. But if we do it the right way, if we use some common sense technology judiciously, and we prioritize appropriately, then I think, you know, we can free up some of those resources because it's 20% that we're not going to have to spend on maintenance anymore. And we can do some other things with that. One of the challenges, though, is that utilities are very risk averse. We have a very different business model than industrial clients do. Industrial clients love to basically say, okay, I have to make this widget or whatever it is, or chemistry, Dow Chemical being, you know, one of the ones that are in David's region, and all those refineries. They make everything for as little money as possible to spend on that production. to that end, they basically have one pump or one or two assets to accomplish a task. The municipal market has a very different business model, and their business model is like, oh, I will always make water. I will never not make water, and it'll always be healthy or healthy for the customer. I will always take sewage, and I will never not take sewage, and I will always end up treating it so I don't damage the environment. To mitigate those risks, they have spent gobs of money in putting in a lot of redundancy. Where 2 pumps might work, there's 5. And so there is a different culture that has evolved in looking at things, particularly from a risk management perspective. Say, well, I need 4 pumps, I better put in 5 just to make sure I never breach on what I'm supposed to do. And I think we can learn a lot from industry that has smartly sized and right-sized the technology applications in order to deliver on their end goal. Yes, the business models are a little bit different, and we need to keep that in mind. And maybe we don't go down to 2 pumps, but we need to apply technology, and we need to apply resources, staff, resources, time. These are all commodities that we're in increasingly limited scope on. And someone had already mentioned the current pandemic. Well, we've had people having to stay at home, and so there are fewer resources even out in the field. So we need technology to be able to, for us to do more with less, for us to be able to capture information in real time, be able to capture the right information, and be able to do very sharply focused activities that will free up these resources so that we can then go ahead and look at some capital plans and do the capital plans at the right time to make sure that we're increasing the value for our stakeholders, which are all the customers that we've been talking about.
Right. Thanks, Tacoma. Just 2 comments. You started by talking about non-revenue water. I remember when I was in Pittsburgh, I went to a presentation by a nonprofit group, and they showed a blurb that said, Santiago, Chile has a 40% non-revenue water percentage, and everybody laughed. And then I got up as the manager of the Pittsburgh water system and said, ours is 50%, we think. And everybody gasped. So, there is some low-hanging, it may not be in Texas, but there is some low-hanging fruit out there in some water agencies. And also on these automatic shut-off meters, some of them, you can throttle back. So you don't have to, it's not binary. You don't have to be open or shut. You can also throttle it back so that there's a lifeline supply that comes through, which is one of the cool things you can do with some of these new meter products. Let's see, we got another question. I hear from other water utilities, their commercial revenues are down due to business closings attributed to COVID. Are reserve funds being utilized to bridge the gap? Terrence, is that something that you can talk to from your LADWP experience?
Yeah, so I can speak to what we've seen on our revenues from the commercial side are down, but contrary to that, our residential revenues are maintaining because obviously more people are at home and using more water. So there's a balance there, but also with the COVID impacts in terms of folks not being able to pay bills. We've only seen I believe it's 40% reduction in late bill payments. And so what that means, it's not 40% of our customers are not paying their bills. It means our late payments have increased by 40%, while a lot of our other payments are still being made. So in terms of using reserve funds, we haven't had to go to that extreme, some of which is a part of our rate structure where we maintain a stable operating revenue based upon our rate structure. Obviously, this pandemic is creating kind of a unique scenario that our rate structure did not envision. But in terms of tapping into reserves, we have not had to do that. And if I could just really quickly touch on what Tacoma was saying about non-revenue water and also speak to what you referenced, Jim. One of the things, kind of getting back to the technology side of things, one of the things on those stats of 40% non-revenue water, 20% non-revenue water, those values, while they may be totally accurate, they're all reliant on data that's being generated from who knows how accurate of a system and who knows when the last time it was validated or you know, calibrated those sensors. And so, you know, it probably is within that ballpark, but there's always that question too of how good is the data coming in that, you know, we're putting out this result of non-revenue water. One of the things that we've done, and also it's been a response to a California regulatory requirement, is we've put together a water loss action plan where we have kind of prioritized those approaches to identifying non-revenue waters and how to address those situations, which really is a great start to trying to identify ways to minimize non-revenue water losses.
Right, and most, at least water meters, when they become inaccurate, they're under measuring. So maybe you're saying that the non-revenue percentages are higher than they're reported to be as a general rule. All right, we've got another question from the audience. This is, they must have tapped into my phone because this is one I had ready to go for the panelists. So thanks, Mal. But the question is, what are the roadblocks to digital technology adoption of public utilities? How can these be overcome? Anyone want to volunteer to take this? We'll do a round robin here, but anyone want to jump in?
I'll jump in because, sorry, I've seen this from both sides of the equation, having run utilities before. And so seeing it from that perspective, and then also actually now providing a solution to utilities, you get to see the other side of the equation. And I would honestly say that one of the challenges is the roadblocks to this adoption is, I'll say it this way. Nobody ever got fired for buying IBM. It's one of these, there's a great show out there, I think it was called Halt and Catch Fire, that basically there's a line from that show. But it's true, there's a lot of legacy software out there that nobody ever got fired for purchasing. As expensive as it is, and as sometimes with waning on the promises that it brings, it seems to be a safe bet. And utilities are extraordinarily risk averse. Part of it is because we have the public interest at heart. When I say we, it's what we used to do. We have the public interest at heart, where we are looking at making sure that people have water and also taking away their wastewater. But at the same time, there are so many checks and balances that go on. And one of the dilemmas I think that we see is that sometimes technologies have been applied, like some of the great stuff that Dave's talking about and some other technologies that we're aware of. And to be honest, like some of the stuff that we've done as well, and they leave it in isolation. So you've got this technology that's out there and it's been orphaned. And they're going, well, we've got this thing, we're getting some data from it, but we really don't know what to do with it, or we don't have a repository for it. We can't sort of bring it together. We really are having a tough time bringing it into a sort of a cohesive one ecosystem. And the challenge then is that it leaves us wanting for the return on that investment. And so I think the notion of being risk averse and the notion of experience of having tried something a little bit and not having gotten a return for it. And I think one of the challenges that we face, and I think one of the things that I know that we offer, is that things have to go lock and step. So if you're going to apply new technology, it needs to be able to communicate with your ecosystem and with your CMMS and your EAM. If it can't communicate with that, you've got an orphan. And I think those things need to go in step. And I know that one of the challenges we've found is that trying to convey that we can communicate with anything and bring that technology and that return on investment back together. But this old technology, a lot of times it's been internally customized. It's expensive to support. And to be quite honest, it doesn't end up supporting the new demands of the asset management programs that are now coming onto the fore of the equation. With the depth of data collection as well, I think people have been left with, well, we couldn't do this and we couldn't do that. And, we spent a year or two trying to integrate something, and it's a piecemeal approach. And so I think, here's what I always sort of go back to. If we're willing to do online banking with our personal finances, why wouldn't we be willing to do online cloud information gathering, cloud computing, and cloud managing of our CMMS? The technology is there. The infrastructure is in place. Microsoft, AWS, they're extremely robust. And again, for some reason, we seem to have this want for being able to take what we would do personally and apply it at work in a municipal context. And I think the solutions are out there. We just need to do more education.
David Collinsworth, does that track with what you're seeing as the head of a public agency? Some of maybe the reluctance to move this direction, or what are your thoughts?
I don't think there's a reluctance per se, and I'll say what I said a minute ago, to work smarter versus harder. I think the reluctance is right now we're from a resource human body perspective, we're really challenged. And I don't care what municipality you are or what river authority you are, if you need 14 operators to operate a wastewater plant, you don't have 20, you have 14. Sometimes you have 13, sometimes you have 12. So to automate and to pull people away from what they're doing and say, you know, we're going to go down this other road and you're going to automate and you're going to trust the data and you're going to trust the computers and you're going to trust the gauges and the probes and all these other things. It takes time. It takes success. You have to take baby steps and you have to implement things that your operators have the time to deal with, have the time to troubleshoot, and you just gotta go into it slowly so you don't overwhelm your resources.
Right. Terrence, you're with the other public agency. What do you think?
Yeah, so one of the challenges we face in addition to what Tacoma and David were talking about is that trying to run new technologies while operating an existing system is a huge challenge, not only just from the infrastructure side and how everything is set up, but also from just that inbred nature of how the system operates, and everybody wants to keep operating it that same way. And so to try and go in and throw in a brand new technology and say, hey, this is the latest whiz bang we got, and this is what you're going to use from now on, there's a large resistance to change what isn't broken. And so, you know, that is a challenge that we face, but how we've tried to overcome it is run these things in parallel. So we keep our SCADA separate from any outside network, so it's not tied to the web or any other thing, and everything still operates the way it used to, but then we have a parallel system that operates with new technologies we bring in, test out, we pilot it, and see how it functions in monitoring and providing input, providing that good data that the operators can see, and they can say, hey, you know, this is the same information that I'm getting in the field. And so this is actually really useful for me because I didn't have to come over to this gauge and read, you know, how much, you know, chlorine's being put into the system or ammonia is being used, or, you know, I could have just pulled it up on my computer screen, changed the dosage amounts, and then we could have kept going here, you know? So I think that's one of the way to overcome those challenges.
And Terrence, you know, to go back to something that Tacoma said about your personal finances in the cloud, you know, I'll give you another analogy based on that. You know, years ago, I wasn't going to swipe a credit card. I was going to continue to write checks. And I don't remember how to write a check now. And I'm of an age that I grew up without portable phones, much less cell phones. So 10 years ago, when my teenage girls were telling me, Dad, text me, I'm not texting you, I'll call you. And now I'd much rather text you. So it's just going to take time, Jim. It's going to take time.
Yeah.
Success is key.
Well, we got a question from our organizer, and so he outranks all of us here. And he asks, is there one or two things that need research that would create great value? Any ideas? And so, of course, this naturally first goes to the professor to answer.
So what needs to be done in terms of research? Is that the question?
Yeah,
Sorry, I didn't see
yeah.
the question. Oh, that's the way it is.
It's under the chat session. I'll read it again. It
Okay.
says, is there one or two things that need research that would create great value? Any ideas?
Well, let's see.
If NSF came in with a $25 million grant for your department
Sure.
for 2 projects, what would you do? What would you look at?
I think the greatest way to research what everybody has described today is, and if there is any resistance in the utilities side because of the lack of resources and times, is that we could possibly, you know, do a pilot scale studies involving all kind of stakeholders, including academics, utility folks, industry partners, consultants, and then we can do a small scale simulation or the study, and we can actually create, create a model. And using the model, we should be able to calculate the cost, life cycle cost of what would happen if new digital technology is implemented, and so we can scale it up to show to the real customer and see what they can say. So I think that's one thing. The pilot testing, and I think one of the greatest example is that at Texas State we have a Cedar initiative. This may be what Andreas is trying to get to. We have an initiative to develop a living lab concept around our Texas State infrastructure, research infrastructure. And that's a great platform for all of us to utilize to pilot test and demonstrate what the latest and greatest of the technology we have in our industry. So that's
right.
my answer.
All right. Well, yeah, I see this as kind of a business development tool. So we've got 3 minutes left. Let's lightning round on the answer to the question. We'll start with Dave Mackie. The 2 things that you'd most like to see researched. And remember, we only have 3 minutes. Go ahead.
I'm sorry, this froze for a minute.
All right. Tacoma, we'll come back to Dave.
I would say AI. I think AI would be a great one to do some deeper research in. There's some companies out there at the university level that have, or I should say a research lab that have done that. Some have spawned off into some companies. I think there's some great promise for it, but I think we need to be really careful about it and not to sit there and wish Terminator into existence. But I think if we get on that, we would be able to do a lot more with a lot less, especially if we can bring some intelligence to it where it makes the sound wise decisions that we are very experienced managers will be making, and then actually being able to do a lot more prediction. And I think that's where a lot of the cool stuff will be as well. So AI and predictive.
And maybe present at conferences. Terrence?
I'll jump in and just say real-time water quality monitoring. I love the idea behind AI and predictive analytics. But one of the things that we're going to be facing is new regulatory requirements about new constituents of emerging concern, and transferring to direct potable reuse and indirect potable reuse. Water quality monitoring is going to become a much bigger thing, and having access to that information immediately so you can make informed decisions on the spot as to what you need to change in the process is going to be huge.
Okay, Dave Mackie, are you online now? Yeah.
Yeah, sorry about that. I'm not sure I have an internet connection here. So I'd close this out with, look, the biggest issue I see with anything that I'm hearing today is the funding and the manpower to install any new initiative is incredibly hard to come by. So I think if you can figure out a way to sort of manage the infrastructure so that it can be painless to do and pays for itself quickly, those are the 2 big advantages. What we see is not what needs to happen, but how do you get the funding to make it happen? And part of our value proposition, I don't want to get too far from the sales pitch here, is we'll get you the money to do whatever it is you really want to do. And we'll do that by finding revenue and looking at these assets in a way that can't be looked at any other way. We do use artificial intelligence and we do use machine learning, but what we're doing with artificial and machine learning isn't inference. It's looking at actual data that's created to see what's going on. So one classic example, we can watch the rotational spin of a turbine within a meter at 1 rotation per minute. We can also listen to see if water's flowing through that at the same time. If the turbine ain't spinning and there's water flowing through there and we can hear it and we can see it's not being registered, that is non-revenue water in a very real sense. Those types of things are the things that are actionable. And to Tacoma's point, we're not trading out the infrastructure to do it. It just needs a repair. Here's specifically what you need to do to repair it. And those types of initiatives, I think, if you can become self-funding and fund other projects as well, that is a real advantage. what needs to happen, I'm sure there's a lot of smart things that need to happen, but usually they're not revenue generative. If you can come up with a way to pay for these programs, that is a real win. And that's really what we're focused on.
All right. And let's end where we began. David Collinsworth, two things you would love to see some research in that would help you?
I'm only going to name one, and I'll name it twice. Okay. I need universities to figure out how to take salt out of water at half the cost. Because once we can do that, then 90% of the water shortages in the United States are taken care of. And then we can just go figure out how to fund projects to build pipelines to move water. The earth is made of water, but it's got salt in it. We need to take the salt out at half the cost.
We just have to reverse thermodynamics, that's all.
Andre, are you still there? Do you want to say anything at the close of the panel here, or?
Absolutely, guys. Thank you very much. Great job. Thank you to the audience. Really a fantastic keynote, and I thought that the depth of your conversation was awesome. So give yourselves a hand. Thank you very much. Good job, and we'll have you again next year. And I know that we have maybe some lingering questions. We will address them to the right people. But Jim, thank you for managing the panel. I thought you did a fantastic job as well. And we are delighted that you're all part of the Digital 360 Summit. I'm going to stop recording now, and we can talk as people sign off and leave the